Hi, this video is for Monday, April 20th for trigonometry. I'm going to start teaching you about vectors. So today we're going to talk about what is a vector and the magnitude of a vector. Okay, so I'm going to read this straight from your notes. Many quantities involve magnitudes, such as 45 pounds or 60 miles per hour. These quantities are called scalars and can be represented by real numbers. Other quantities, called vector quantities, involve both magnitude and direction. Typical vector quantities are velocity, acceleration, and force. A vector quantity is often represented with a directed line segment to indicate the direction, and this is called a vector. So the length of the vector represents the magnitude. And a vector can be represented like this. It can either be bold letters, so let's talk about this vector OP. So it can either be bold letters or it can look like this. And this indicates that O is the starting point and P is the ending point. And this is boldface print. Pretend it's boldface print. So it's either boldface and they're both capital letters, or they're both capital letters and an arrow indicating which direction it goes. Okay, so the magnitude of this vector, magnitude is written with absolute value bars around it, like this. And that represents the distance between O and P, or the length of the vector overall. So I'm going to teach you that formula today. All right. So again, magnitude of a vector is basically the length, and it's either represented with one absolute value or like this. So if this were vector A, this represents its magnitude. If this was vector OP, that could represent its magnitude. Okay, so the magnitude of a vector, this is the formula. Now, this is assuming that the vector starts at the origin, 0, 0, and the vector itself ends at that point, A1, A2. Okay, so vectors are represented by these little brackets. Okay, so kind of like X's and Y's. This would be the horizontal part, the X part, and this would be the vertical part, the Y part. I really wish these people would stop texting me right now. It's annoying. Anyway, so if you hear lots of buzzing, that's me. Sorry. Alright, so that's how you find the magnitude of a vector. We're going to take each part, so A1 squared plus A2 squared, and then you find the square root. Alright, so here we go. Alright, we're finding the magnitude of all these vectors. Alright, so we're going to square each component and add them together. So 2 squared plus negative 4 squared, and then we're going to take the square root of that. So 2 squared is 4, and negative 4 squared is 16. And if you take the square root of that, that's the square root of 20. Ow. Hit my elbow on the chair. Square root of 20, if you round to the nearest tenth, is 4.5. Okay, so on your homework today, we will be finding the magnitude of a vector, and then you'll round your answer to the nearest tenth. Okay, so it's important that you round it to the nearest tenth. Alright, part B looks like this. We've got negative 3, 0. So we're going to square each part. So negative 3 squared is 9. 0 squared is 0. And if you add those together, that equals 9. And the square root of 9 is 3. Okay, so really it's just a matter of squaring each part, adding them together, and then taking the square root. So hopefully that's making sense so far. We're going to try, let's see, one more problem like that, and then I'm going to talk to you about something called horizontal and vertical components. Those will not be on your homework today, but we're still going to talk about them, just to say that we did. Okay. Alright, so this is still example 1, part C. Our vector is -2, -2, and we're going to square both parts. So -2 squared is 4. Okay, so 4 plus 4 is 8, and the square root of 8 is 2.8. Okay, so like that. Alright, so that's how you find magnitude of a vector. Hopefully that makes sense. That's what your homework is going to be on, but we're going to talk now about horizontal and vertical components. So I'm going to read this from your notes. The horizontal and vertical components, respectively, of a vector u having the magnitude with the absolute value bars, so the magnitude u, and direction angle theta are given by this formula. So before we talk about the formula, I'm actually going to draw you a little picture so that makes more sense. Okay, so if you have a normal coordinate grid like this, pretend that's straighter than it is, okay? So your vector, these vectors are all starting at 0, 0, which is the origin. So if you had a vector, let's say it goes this way, okay? We'll call it OP since we've been using those letters, okay? So if this is your vector, its angle theta is going to be this angle here. Okay, so this is the angle theta that they're talking about, and it has a horizontal component, meaning how far do you have to go over to be in line with P, and then how far up do you have to go, like that. So that's basically what we're talking about here. So now I'm going to present you with the formulas. Okay. So we have A equals the magnitude of the vector times cosine theta. And B would be the magnitude of the vector times sine theta. So in your vector, A, B, A is kind of like X, B is kind of like Y. And a long time ago when we first studied trigonometry, cosine went with X, sine went with Y. So here, cosine is going with A, and sine is going with B. And since A and B are being used instead of X and Y here, that kind of makes a little bit of sense. Okay, so in this problem that we're about to do, they're going to give us a magnitude and an angle theta. Alright, so it says vector W has magnitude 25. So where you see these magnitude things, we're going to put 25. Okay, and direction angle 41.7 degrees. So this would be cosine 41.7, and this would be sine 41.7. So if you had a picture of this thing, and our angle, this is a very rough sketch, so bear with me. Our angle here would be 41.7 degrees, and I don't know what A and B are yet. This is like A, up is like B, but I do know that its distance here is 25. Okay, so we're going to multiply those things that I put into the formulas now and get the answers. And we're going to round to the nearest tenth. Okay, so right here, this one, 25 times cosine of 41.7. and that is 18.7. Okay, now we're doing this one, so 25 times sine of 41.7, and that equals 16.6. So B is 16.6. Alright, so this will not be on your homework, but I did want to talk about it just to say that we did. Your homework for the day is magnitude. So that was the first examples we did, and if you need any help finding the magnitude of a vector, please let me know. Your Google form for the day is a short answer type Google form, so you'll have to figure out the magnitude and then round it to the nearest tenth and put that number in the box. Okay? So if you need any help, let me know. If you're having problems submitting your Google Forms, please let me know. Some people are having problems with that. I don't really know why, and that's frustrating, but if you're having any issues whatsoever, just let me know. Okay? I miss you, and I hope you all are well. Bye.